Welcome to this talk on dynamic template boxes and other advances in typesetting. I'm Jason Harris. I'm one of the senior developers in the front end. I introduced TemplateBoxes and I work on that along with my colleagues. And this is coming to you from New Zealand. Okay, so in this presentation, I'm going to quickly go through a recap of some of the stuff to do with typesetting, boxes, the underlying representation of things in the front end, the box representation, in an effort to just get up to speed and being able to actually talk about template boxes, which are now basically the standard representation of how we do a lot of the advanced typesetting in the front end. And so to do that, I'll cover some of the material I've covered. It's very quick, zipping through to do with boxes, style sheets, and make boxes and make expression rules in Mathematica. And once we've got that basis, then I'll actually move on to being able to talk about template boxes, the style sheets, association template boxes, and actual dynamic template boxes. And dynamic template boxes unify basically the dynamic paradigm to do with and marry that with template boxes, and using these we can encapsulate a whole lot more than we really could before, and basically they're going to be everywhere in the front end coming up. And finally we'll round this out with an in-depth discussion on substitution and scoping in template box display functions. Right, so to start this off, this all got motivated way back when about typesetting. And so in Mathematica right now, if I evaluate that, Mathematica doesn't understand this. It doesn't understand that particular notation. And of course, we can extend Mathematica, and we do this all the time internally, but this is what sort of kicked it all off. And then from that, we had some advances in typesetting, and then from there, we introduced template boxes, and then from there, we generalized those, and now we're generalizing them again. Okay, so to talk about that, let's actually talk about what boxes are. So if I type this in the normal editor in Mathematica, we can actually see, if I use this cell show expression, we actually see the underlying structure, and we see this x cubed is represented by a superscript box of x comma 3, and this whole grouping is represented by a row box. And in fact, we could turn around and we could edit this expression, the actual boxes, and would see this reflected in the two-dimensional typeset. And of course, we could use the normal Mathematica editor, the 2D editor, to change our expression. And the same is true with more complicated expressions. Here we have this integral, we have a subsuperscript, and of course, we could go in and actually just change one of the particular excuse me, variables here, change that z to a 2, for instance, and it functions as you'd expect. Okay, so we have this difference between this visual form, this 2D form, and the actual internal form. And so I can take a look via an input field with continuous action goes to true with boxes. As I type this into Mathematica, we see what is the underlying representation of this in Mathematica. And this would be in terms of boxes. And we see it's a flat structure. And if we change this plus, for instance, to a times, we actually see it groups differently. Okay, so, and of course, if we type in something a bit more advanced here, just the expression we had before, that's now a subscript box. We go to the opposite limit. It's now a subsuperscript box. We type in the exponential e, some powers, minus x to the, x squared, and the differential d, x, and so on. And so as I type this stuff into the Mathematica editor, we see the underlying boxes reflect this. And so the front-end editor is actually a box parser. It's not a text parser, it's a box parser. And so together with my colleagues is responsible for this and sort of other things. Okay, so these boxes underline the math, and you might say, well, that's all good for math, but what about graphics? It turns out graphics is actually made up of graphics boxes with line boxes, and even other primitives like a Bezier curve is made up of the Bezier curve box and point boxes. And so they're boxes. So all graphics are boxes. Styles, for instance, that's made up of a style box. Buttons here, as we click on them and move through them, we can actually see a button as a button box, and it's got a button function. And most importantly for this talk, a slider, as we move the slider and values from 1 to 100 in steps of 1, we can actually see that underneath the slider is actually a slider box, and our dynamic is actually a dynamic box. And so there's this dance between these dynamics. As we move this, it's setting the value of mn in the kernel here, and this is dance between the front end and the kernel, where these updates get sort of sent back, and we get dynamic updating. And so in the end, it's all about boxes. Everything in the front end is a box. So how does this actually work in practice, this dance between for notations and go between the front end and the kernel? Well, let's take a look at this example, partial y is sine y over 2, and we evaluate it. We obviously get, cosine y over 2, derivative of sine is cosine. What's going on here? Well, we start off in the front end with this box structure, and it's graphically displayed in this two-dimensional form like so. But that is, of course, represented, as we've seen before, by this Command-Shift-D. It's represented by these boxes. And so it's got this representation in the front end of the boxes. These boxes then get sent off to the kernel, and through make expression, the kernel gets a new expression in a sort of textual form that you can imagine it like that gets evaluated in the kernel. The derivative gets evaluated to a cosine y. Then the kernel generates boxes through make boxes, gives us boxes, and sends that back to the front end. And those boxes are then displayed in this two-dimensional sort of typesetting form, which then is displayed like so. And of course, that is how we perceive evaluation to occur in the front end. This is what's happening when I get this and I hit Shift Return. It's actually doing this dance of sending the boxes, parsing them, getting it, evaluating the kernel expression, and sending it back to the sort of front end. And you could evaluate this in Link Snooper to actually see what's going on there. Right. Okay, so it's instructive here to actually work through this example that we had before, this partial plus of v that Mathematica doesn't understand right now. So what's happening in this diagram is Mathematica doesn't know how to parse it. The make expression going from the box structure to kernel expression, Mathematica doesn't know that. So if I have make expression of some boxes, of these boxes, which boxes? These boxes, I'll grab them here. If knowing that in standard form, it doesn't actually know what to do with them. And you can see it's got this error box. And so what we can do to actually add the notation, we can tell Mathematica that, well, the value of that make expression is actually the make expression of some other boxes that it does know how to make. And which would be the other boxes that it does know how to make? Well, it knows how to make that. It's a normal standard sort of head, and those boxes are represented by something like so. And so we can copy that, paste it in here, and now Mathematica will understand this particular notation, which is good, but it's not general. If I change it to a Q, for instance, it doesn't know that, so we need to change this to a pattern here, V and a V underscore here, and now Mathematica can really fully parse this, and it's over Q over 2 or so on. Okay, so it actually understands this PD plus, but we don't actually have the formatting that we had before. We're going from this PD plus form to a nice box structure like so. So we can actually turn around and add it here. So we're going to add a make boxes rule, and it's going to be a PD plus of some, we're going to make it general now, since we learned our lesson, is going to be some set of boxes. Well, which boxes? Well, these boxes, of course. And so that looks good. And if we evaluate this, now we see, oh, it's got the cell context thing. Why is that? Well, this is an expression. So make boxes takes an expression and gives us boxes, but this is actually still an expression. So we need to further make that with make boxes in standard form. Okay, so now as we evaluate this and so on, we've really introduced, we've done both sides of the parsing and the formatting, and we've added a new notation. And now that we've got this notation here, we can define rules for it. Here's the simple distributivity over addition, and this will evaluate as you sort of expect. Okay, so I am flying through this examples because I need to get to the bits to actually talk about template boxes and so on. So one of the points to actually note is that it's actually quite easy sometimes to enter in expressions in terms of the normal typesetting as normal input, and actually then finally, once it's actually there, do convert to standard form or traditional form or something else like that, and to actually get a nice formatting, a 2D formatting representation of the actual structure. Okay, and so I should just mention in passing, just as I'm zipping by, and make boxes and make expression, you actually have to worry about evaluation. And so let's just give a couple examples of this in application. Here we see a sort of function. And so Stephen mentioned this in his keynote, and it's represented like this. We quite like this particular form. Maybe we want this to be everywhere. And so what we could do is we could tell Mathematica that in general, when you're making boxes in standard form of this particular function of 2 arguments, well, it should look like this. And we'd have to make the boxes further to do this, but then it will work as you'd sort of expect. Okay, again, I'm sort of flying, see previous talks. This is a bit of a recap. And so now if I evaluate these particular expressions, then this will now be understood, whereas it wouldn't be before, and we can add various things like this, and it all parses and works as you'd expect. Okay, so with that, let's move on now to the main topic here, template boxes. So what are template boxes? So here's a template box. I can tab between the various arguments. I can change them. I'll reevaluate this, and it'll evaluate as you'd sort of expect. So given the previous background that we know that this is represented by boxes, we can say, well, what would be the boxes for this binomial? Well, it's probably going to be some grid boxy sort of thing, an opening bracket, a closing bracket, and would expect it to sort of look like this: row box of grid box of placeholders. Okay, so let's actually take a look at the underlying expression, and we actually see that it looks like this. Which is not, it doesn't, we don't actually see here any of the grid box at all. In fact, we see some sort of arguments. As I change this here, then the templated argument, you can see it's reflected in the argument list as I've changed this. And moreover, the evaluation, I don't see any sort of binomial. I've only got this as a tag. If I change this tag, somehow to here, it's looking now like a Bessel function. And I can go in and change the various arguments, and it evaluates as a Bessel function. And so just by this name alone, it's got both evaluation and display. If I change this to Legendre P, Legendre polynomial, it will evaluate like a Legendre polynomial. And if I change it back to binomial, we get back to our normal display. How is this happening? How are we getting both the display and the evaluation characteristics just by changing this particular tag? Well, TemplateBox has options. And one of those options is the display function. And the display function is a box function. And what's a box function? A box function it's a pure function that takes box arguments and produces an actual box at the end of it. And what does that box look like for this particular example? Well, it looks like this, PA of W. And we could change the box function, a Q, and change one of the arguments, K, for instance, here, and get a different sort of output. So what the template box does is it takes its arguments, it plugs them in to the box function, and it uses the resulting boxes as its display. And so this template box now appears like so. And of course, if we change the particular arguments, they get passed in. The template box extracts that arguments, and so they're templated arguments. And so as I make changes here to the actual templated arguments, I see that reflected in the arguments of the template box. And in fact, if I evaluate this, I get what it'll do is it'll wrap, if that's a string head, it'll wrap that head around the argument list to produce the actual resulting expression. And so if I change that tag to some other tag, we'll get a different full form expression. And that's because of the default interpretation function is automatic. Okay, so that's all well and good. Let's actually take a look at a further example here. We have a my commutator, and we've had to actually specify this display function as before. It's a pure function of two arguments. And so what's the real advantage of doing this template box if we have to specify this display function all the time? Haven't we just moved the boxes to somewhere else? Well, it turns out if we don't specify the display function, there's a question of how does it resolve this? And right now, there is no resolution for the display function here. It's missing. It still works. It'll evaluate, but it just doesn't know how to display this. So what happens with the template box? If the actual tag here is a named style on the style sheet, it'll use those styles to style the template box. And so if that name style on the style sheet here, we have a style that actually has the display function option set, it will be used to style the template box. So I've written this inject styles here, inject styles, and this will simply put in styles, a name style onto the style sheet if it doesn't exist, or change it if it does. And so we're going to set some options here, template box options, and we're going to set which option? Well, we're going to set the display function option. And so now this will create a style on the style sheet called my commutator with these options set. And once that's set, this will now be resolvable and will actually be able to be styled. So if I evaluate that, we actually see this is now displayed because it's getting its display function from the options. And of course, this works as before. And in keeping with before, my commutator here, it doesn't have a nice sort of display. We haven't made a make boxes rule, so we could go in and we could add a make boxes rule for my commutators to be displayed as a template box and so on. And now this would be a sort of full notation. And of course we could go in and change this, my commutator to be, plus or something, and it'll change the various my commutators around. And we'll go back to, minus here, for instance. Okay, so so that's a template box. So more formally, a template box is a list of box arguments and a tag and some options. But if that tag is a string tag and it corresponds to a style on the style sheet, and you can see we've now got styles here, this my commutator is being added here to the style sheet. Then those, in fact, I'll actually show the my commutator. You can actually see it's got the subscript box, and it's just exactly the style that we had added. And so this tag will be used, the style, the display function from the style sheet will actually be used to style the template box. Okay, one other thing to point out, of course, is we can nest these template boxes, and as would evaluate that, we see this binomial Legendre T. We can tab around them and see the various arguments. And of course, this binomial, let's actually, now that we know the sort of trick of what's happening, we could actually go to the go to the core style sheet, actually go down and find binomial, and would see that's a style in the core style sheet, and it has indeed set this template box options display function goes to something we originally thought, this grid boxy sort of thing, to actually to style its display. So of course you could change, and you could add, a binomial style here, which is different, which overrides it, which gives a different style to the template box. Okay, so we added in 12.1 template box associations, and that's sort of necessary, yeah, it's necessary to know what those are for dynamic template boxes. So let's do this by an example template box. So we're going to make a template box here with an association list of arguments. So instead of just a list of boxes, we're going to make a list of named boxes, and we're going to call this derivative, and it's going to have a display function, and it's going to look something like that. Okay, so now we need to fill in the bits. What are the arguments to the named arguments to the template box? Well, just for simplicity's sake, so you can actually see them in the association and know the mapping, we'll just use lowercase for the arguments here, so you can keep them straight, and like so. So those are now the arguments to the Lie derivative template box. And now what's the display function should it be? Well, let's actually grab those boxes of what it is here and put those in. So instead of now being, #1 as a pure function, it's going to be using the named arguments here. So it's going to be using string slots. So it'll be, #x, #y, #t. #t, and now this will actually display, what did I do? Row box display function. Oh, raw boxes. Raw boxes. You can tell it's live. So you can see this now, this display function, as I come in here and I change the particular variables here, you can actually see that those arguments are now being reflected in the names are the same, of course, but the values are changing in the template box arguments via this association. And it has the right behavior. It evaluates as before because we've called this Lie derivative. Okay. And so as before, we generally, in the template boxes, we don't have this display function. It's very much not the norm to be explicitly specified. So let's actually go ahead, again, put it on the style sheet. And now we have this template box with Lie derivatives, and it displays as you'd expect. And it's, short and brief, and we can change the various parameters as we could before, and it evaluates. Okay, so that's Lie derivatives. I'll mention as well missing arguments and template boxes. And why is this important here? Well, so with missing arguments here, since it knows the display function, we can actually, it still displays in a nice way. And so we could, fill this up and it would, have the right form. We've still got the rules active for my commutators. And the same way with the Lie derivatives here, we just have this template TemplateBox with no association with association with no values, and we could just fill in the particular values if we wanted, and it would work. And why is this important? Well, in the end, we'd maybe want to actually put this in as input alias. I think that's that one right there. And so what's a good input alias for a lead derivative? Maybe LD, for instance, LD. And so now we can just enter in the lead derivative like so, and add to another lead derivative like so, and put it in and templateize it and put some bits in, right? And it all works. Okay. So it's missing arguments. I'll mention slot sequences. Slot sequences in Mathematica, if I take a look at that, if you know enough about pure functions, this is actually a normal thing in Mathematica. And I won't talk about it too much. Then let's just see, is there any questions at this stage? Happily, my computer here has gone to sleep, and oh, come on. Right. Okay. I can't see if it's got any questions. Let me log in. Yeah. So I'll answer questions at the end. So if we then, in the same sort of spirit, if we take a look at this with our template box, this template slot sequence will gather up all of the various arguments from the first argument onwards, and we could put in a riffling element here, for instance, to actually sort of see that. And of course, we could go from not just one, we could go from maybe, I don't know, 2 to the 4th argument, and so on with our template slot sequences. And of course, they work with association values. This is a template slot sequence, which is going from the bth element through to the end, and we could go from maybe the bth element through to, I don't know, the eth element, and you'd actually sort of see this would be v, w, x, and y, as we'd sort of see it here. Okay. So I wanted to also mention one other thing while we're here, this template box highlighting here. This particular box has the option editing highlight argument style and highlight style set. And so you can actually see as we edit this, you can actually sort of see the extent a little bit more of the particular templated arguments and the whole template box itself. And of course, since these are arguments, you can specify them on the style sheet. Right, we're finally up to dynamic template boxes. So what are dynamic template boxes? Well, let's actually start with the example here, dynamic of x, and a slider of dynamic of x. So as I now change the value of the slider, we see this globally, what the sort of cell context x is actually changing as I change this value of the slider. And likewise, if I have a second slider, these are all linked to this $sign context, cell context of x. And so what I'd like to do is I'd like, instead of the updating of the slider to be updating sort of some x, I'd like it to be updating a template argument. So let's see if we can actually do this now. And so in Mathematica 12.2, this will actually work. In previous versions, TemplateBox, it won't. And so we're going to give it, let's give it, for clarity, an association template box. And so we'll start it off with initial value. A will start off with an initial value of 0.3, for instance, and we'll give it a name, dynamic slider, could be anything. And we give it a display function here, display function, and it's going to be some display sort of function. And what is the display function actually going to be for this template box? Well, it's going to be this. So we're going to go grab the underlying structure, paste it in. And now, instead of the cell context of x, what are we going to use? We're going to use the string slot A. And so now, as I move this particular slider, it's actually going to be reflected. It's going to be extracted, and it's going to change the value of A in the template box, in the template box argument. So instead of being a template argument that we can edit before, the dynamic now is feeding back through instead of to some global A. If I take a look here, A, it's not being set. We see it's independent. It's independently scoped. It's changing the actual argument of the association. So it's feeding back into the argument list of the template box. So kind of simple, but actually quite powerful, as we're about to sort of see. And it's this is generalization. You might think, well, of course, that's pretty obvious, but it took a lot of work. And so we'd have, did I use the right name here? Dynamic slider. There we go. Okay. And so so from here, I've added this dynamic slider to the options to the style sheet. And so here we can actually see it's just a template box with a dynamic slider. And as I change that slider value, it's changing the value in the association. So I can add the display function just like in the other cases to the style sheet. Let's take a look at some further examples that are a little bit more complicated here. And so it's not just just this one particular form. We could, have this as would have a normal structure. It's got many sort of dynamics or dynamic contractions or components or bits of the function to it. And so here we see a slider box together with a dynamic box. And now as I move this sort of slider, we see it's reflected here in the argument list, as well as in this other dynamic. So both of these are referring to the same value here, A. And in fact, we could have two sliders, slider box here and another slider box here. And now as I move that, you see we're updating the value in all of the various places all consistently. And of course, we don't just need just sliders. We've got a checkbox here of dynamic of A. And of course, it's reflecting again that value into the template box. Okay, so that's the basic bit behind dynamic template boxes, but why are these powerful? Why are these actually sort of useful? So let's take a look at RGB color here. And so this is a nice interface. It's got, we can change it and it updates, and it's got the right full form. You've seen this in Mathematica for a while now, so that's all great. But what does it actually look like underneath now that we look at boxes? And if we take a look at this, we see, ooh, it's an interpretation box, of a button box, of a tooltip box, graphics boxes with different base styles and different image sizes that are dynamics and padding and button functions and attached cells and front-end resources and different methods. And it's really quite long. So what we'd like to be able to do is, if the information is the same every time, to actually just specify it through a display function on the style sheet. And so now we can actually do that. And this will be, it's just a simple template box. It's basically just a color. And then all the rest of this is all of the dynamic template boxy sort of stuff, as now we can actually bury it onto the style sheet and make it a very clean interface, which is actually sort of forward compatible. We can change just the style sheet and everything will work in some sort of future version. In this particular version in 12.2, once we hit OK, it's just for this current version of compatibility, we were actually jumping back to the current version of the boxes. But in a future version, because we've added this for sort of backwards compatibility, so if you load a 13 or 14 or 15 version notebook into 12.2, then it will be able to display it correctly because of this stuff we've added to the style sheet. So another example of this is the control equals interface. If I just hit here, I hit control equals, and we take a look at the underlying boxes here, you see it's quite large. It's got these various boxes and so on. And of course, with the new, if we give it the dynamic template box treatment, we can actually turn around and just have a simple template box, just the various names of the various parameters, and actually just the simple template. And it works as before, and sign y, and it'll go off to Wolfram Alpha and give us the particular value that we would expect. Okay. So how do these work internally? I really should be able to get my up here. To see if there are any questions. No questions so far. So how do these work internally? So the dynamic template boxes basically work via internal dynamic module. So let's take a look at, again, a dynamic of X here, as we had before, and a slider of dynamic of X. And as we've noted, these sliders are linked into this cell context of X. But what we could do if we don't want them linked is we can actually group this with a dynamic module box and actually turn dynamic module here, sorry, and give it some scope that particular X with a dynamic module. And now any of the updates for the slider are restricted to this dynamic module, and they don't escape into the general context. And in fact, the dynamic module will record this, or the dynamic module box in the box will actually record the particular value, and it'll persist it even if we actually sort of save it. So that's basically what we actually do with our dynamic templates. But just before I go there and talk about that, let me then talk about here just function application. So this is my last major slide. And so here we have normal function application. This is a pure function on slots on A and B, and we see it evaluates to a plus b squared. And here, instead of using numbered slots, we could use string slots, acting on the named parameters via the association, and that also gives us the particular answer. We could as well use a dynamic module, just like a normal module, if you'd expect. And so x is locally equal to a and y is locally equal to b, and that will give us the same sort of value. And indeed, for a dynamic module, it will give us the same behavior. So what happens? So that's our, instead of our function substitution. So for our template boxes, our dynamic template boxes, here's one with a slider and the dynamic boxes. We can actually see it. What actually happens underneath the hood is this display function is further wrapped with the dynamic module. And so let's actually do that. Dynamic module box. And so let's give it this parameter a, and we'll assign it to be 0.3 because that's the value in the template box argument. And now we'll give it a box expression to display as. And of course, this we don't want hash a, we just want a, and it'll look like that. And of course, what does that actually look like? Well, it looks like this, quite a bit like our template box. And our scoping, of course, is it's scoped to the dynamic module box as we change this. And in fact, really internally, we give it a different sort of parameter here. It gets rewritten to something else like that. And so the internals basically use something a bit more like this. As we change the actual particular value, the internal dynamic module box gets updated, and the template box will sort of extract that and use that as the value of the argument. And so this automatic wrapping via an internal dynamic module box happens for dynamic-like arguments, things like, slider box, the dynamic here, the dynamic box, dynamic wrapper, button functions, action menus, and so on. And so, in fact, given this, you might actually turn around and say, well, wait a sec, did we really need this to be an association? Couldn't we have just actually turned around and given it 0.3 as just an argument, instead of having a name slot here, have just a numbered slot? Wouldn't that actually work? Well, it actually would, but it's only working now because I've turned on a super secret option for 12.2 for developers, so they can actually test their code with the future versions. So right now, for the default setting, we only do this dynamic template box behavior for association template boxes. And the reason why this is that it's actually subtly different. So this scoping is actually subtly different. If I put a hold in here, by the normal function evaluation here, it still injects this value. This b is replaces the slot 2. The same way here, if I grab that here, the hold, and if I wrap that around the named slot, the string slot, it still evaluates, it still gets injected via the substitution. However, if I wrap it around this particular argument, it doesn't work. Just like, this is the difference between, with and modules. It won't actually be evaluated. And so that did cause some problems, and we've worked around all of them, but just for now, for this 12.2, the numbered slots don't actually work in a dynamic template sort of way. You've got to use association slots or associate string slots in your associations. Okay. So I've gone through this. There's a lot to sort of cover. I've gone through this quite fast. Things I haven't talked about are the interpretation function, copy function, the notation package to be able to allow you to create nice notations, syntax form to allow you to change the precedence and behaviors, the grouping of the various operators, base style and default base style, which all the sort of boxes take, context-dependent parsing for like graphics, tag boxes, and sort of many other things. So I'm just going to hit the forward arrow and get to your conclusion, get to your questions here. Right. So in conclusion, for a template box, we can actually enter, to create one, you'd enter a structure in 2D typesetting. You'd get the canonical boxes that the front end produces that are nice and in the right form, use those, make a display function with them, and parameterize it either with a numbered slots or string slots for an association type template box. You get the resulting sort of display function, put it on the style sheet, create a make boxes rule, and for bonus points, create an input alias for your new notations. So the whole idea of putting it on a style sheet is this greatly enhances forward compatibility. We can change the underlying, and because of these now get quite big, these expressions, these constructs for these various interfaces. And so we can change various aspects of them. They're much more readable. It leads to a great reduction in file size, and so on. And so, iconize the summary boxes, all the various neat stuff, and like we've got in our neural nets, all of those kind of boxes that we produce, they'll be getting in the fullness of time the dynamic module box, the dynamic template box treatment. Okay, and just before I round out, I'll mention there's other interesting very interesting front-end talks. John's, Yusu's, James's, Lou's, Noah's, and Ian's, and Jason Abernathy's. Probably the closest one to this talk is maybe the building contextual interfaces, maybe Noah's talk and drawing tools, then maybe Jason's, Abernathy's talk and typesetting with table views, but they're all good, and you should go to them all. Right. Okay. Questions. So Nikolai asks, it seems this would play very well with interpretation function. For example, adding two sliders together that were like they were numbers. And in fact, yes, you can actually do this. And so if we go back to our slider, this particular example of a dynamic slider, here we can actually evaluate that and see it's there. Add that to another dynamic slider here, and we can add that and have different rules that would actually be able to turn around and give some particular values and interpretation functions to do various things. We'd be able to do that. Okay. Are there any other questions? This room will stay open. I know I'm way over time. Sorry for when will this all work in the cloud was one of the questions. So I talked with Jan. Jan was in this when we introduced this in an internal sort of meeting, and yeah, Jan was yeah, he's got to actually do it, and it's a very good question, and I don't know the answer to that. His work's cut out for him though, so it'll be interesting. So then Jerry asked, doesn't reliance on the style sheet create problems when other users change to another style sheet? That's true for if you're actually, you're writing a package. If you're writing a package, you'd want to actually load it and use something like this inject styles to make sure it's loaded onto the particular notebook that you want. But more importantly, for if you're adding it at a core level, the core style sheet is almost always present for all the particular users. And so if we add stuff to the core style sheet, this will be available for everybody. If you add it, then you've actually got to make sure that it's either on your path via inject styles. One of the things we were looking at was being able to actually add styles to a sort of front-end session. And so that's a sort of ongoing discussion that we've got at various stages. Okay. Well, oh, Francisco's question 3 up. Maybe this was in the chat. I don't more chat. Blah, blah, blah. No, I don't actually see Julio. Yeah, a good question about what happens in a 12.0 notebook with association type template boxes. Yeah, I'm not actually sure. Yeah, I don't know. I think it might just pink box actually. It's really not of the right form. So I haven't actually tried it. So yeah, good question. Yep. In fact, now that I think I'm just about to hit the time where this is actually going to be cut off, I could actually turn around and I don't know, can I open it up so that everybody else can actually talk? I'm not too sure if I could do that. If there are any sort of further questions, is there anybody that would like to sing out and chat? No, I think it's gone. So I think that's the end of the particular the session there. Are there any more questions? If not, you can reach me at any time. I'm Jason H at wolfram.com here. So reach out to me. I'd love to talk with you. Thank you very much. Okay. Bye, everyone.